3 more examples that we're going to work on now. Again, feel free to try any of these on your own first if you'd like, or I will go through them quickly in this video. So starting with the first one, you may recognize that we have a squared here. You may think, a chain rule. Can we reverse the chain rule? We can sometimes, but we're not learning that yet. And this one actually doesn't work anyway if we wanted to try to reverse the chain rule. And so what I think everybody does know how to do here is that we can simplify this by expanding 3x plus 2 over x times 3x plus 2 over x, which gives us 9x squared plus 12, I believe. And you can check my math. I am expanding here, but I'm not writing it all out because this is HL, plus 4x to the negative 2 power dx. And I still have the integral. I haven't integrated, I'm just expanded. Now I can integrate, add 1 to the exponent, divide in front by the new exponent. So 9 divided by 3 is 3. Add 1 to the exponent, that just becomes 12x. Divide by 1 out front, sure. Plus, add 1 to the exponent, that's x to the negative 1. And then multiply by negative 1 out front, so that actually becomes minus 4, x to the negative 1 plus c. Next, we definitely need to simplify this messy disaster first. I'm going to rewrite this maybe as x squared minus 2 divided by x to the 1/2 power dx. And that gives me 2 minus 1/2. So that should give me the integral. I'm not integrating yet. I'm still just simplifying. That becomes x to the 3 over 2 minus 2x to the negative 1/2 when I divide each term by x to the 1/2 dx. And now I can just use the reverse power rule, add 1 to the exponent, 5 over 2, multiply by the reciprocal in front, 2/5. Also, add 1 to the exponent, x to the positive 1/2, and then multiply by the reciprocal out front, so multiply by 2 in front. So that gives us minus 4 plus c. And finally, the last one. I'm going to rewrite this a little bit differently to help us see. The integral of negative, I'm going to rewrite this as negative 2 over x plus dx plus the integral of 3e to the x dx. I just split up both integrals. Again, I'm going to show you why, because I think this first part sometimes gets confusing for students, and I'm going to want to show you how to integrate this and why it works. I can first actually take a negative 2 out of this. We've seen that pull out the constant rule. So we have negative 2 times the integral of 1 over x dx plus, take the 3 out of this one, e to the x dx. So I just took the constants out, and then from there it's pretty easy to see the integral of 1 over x, we've learned already, is the natural log of the absolute value of x plus 3, and we know the integral of e to the x is e to the x plus c. We don't have to write 2 plus c's, because if you add 2 constants together, it's still just a constant. So we're just going to write 1 plus c at the end, and that is our final answer.